So thanks very much for joining us today. We're going to go through maths percentages. Percentages is a massive part of level 2 functional skills. In your test, you'll get a wide number of questions on percentages of all different kinds of ranges and details. So it is important that you're aware of this. What I'm going to go through today is showing you the relationship between fractions, decimals, and percentages. There was a workshop, I think last week, maybe the week before, on fractions. So if you didn't do that and you haven't got the recording, let us know afterwards and I can send that out to you. But I'll show you the link between those and decimals in there as well. And you'll see why that becomes useful as we go on the presentation. There's then sort of three kind of areas, maybe four kind of areas that the percentage questions ask. One is where you're given an amount, you're working out amount when you're given a percentage. The other is you're given an amount and you've got to work out the percentage from that. And then the third or fourth are calculating increases and decreases in percentages. And then also this thing called reverse percentages. So don't worry too much about the terminology, but hopefully as we go through, you'll see that I've covered all of those as we go through. So I said percentages are everywhere. If you go to the shops, which we can't do at the moment, but if you go to some shops, they'll say 20% off, or VAT is, I don't know what VAT is, 20%, and we pay a percentage in tax, and we have sales and all those kind of things. So percentages all around us. Been around for a long time. Actually, the ancient Romans apparently didn't use the term percent, but they did use fractions of 100, which is obviously what we're talking about. Percent literally means, it's a Latin term, out of 100 or per 100. And the symbol is actually a Latin symbol as well. I found out doing my history that it was first seen in 1650 was the symbol that you see there for the percentage symbol, and we obviously still use it today. So percentage basically means percent or out of 100. What I'm going to do for today's presentation is go through some information on the PowerPoint, but mainly I'm going to be using, if I can get access to it, a whiteboard, and hopefully you can all see the whiteboard up on the screen at the moment. If you can't, just let Eamon know in the chat, and we're going to be looking at percentages. What I'm going to work through is some certain examples. So one of the things about percentages is there's a number of different ways you can work them out. We're talking about percent out of 100, and there's lots of ways to do that. If you've got a calculator on you, you'll probably see there's a percentage symbol on there on a lot of calculators, and you can do certain things with that. I personally, although you can use a calculator certainly for some of the maths test, if not all of it, I personally try and avoid relying on using the percentage button on the calculator, just because it can be a bit confusing, especially if you're doing increases and decreases. So I'm going to talk through a couple of ways that work out percentage. As I said, there are other ways as well. And if you've got a way, if I'm going through something you think that doesn't work for me, but I know I do it this way, that's absolutely fine. However you do it is entirely up to you. The methods I'm going to show you is what personally I find useful and what over the years learners have generally said make a lot more sense. But as I say, if you do find another way, great. Similarly, if I go through things and you say, do you know what, that's not just not working, at some point separately I can send you some details, or we can have a one-to-one session with myself or Eamon, and we can go through some of the other methods as well. But hopefully what we go through is useful here. So I said I'd talk about this relationship between fractions, decimals, and percentage, which I will do. And again, whether you're on the fractions call or not before, you probably recognize a fraction as a number over another number called numerator and denominator. So that fraction is a third, 1 over 3. So in other words, what that's saying is we've got something that's in 3 pieces and we've got one of those pieces. The example I gave on the fractions webinar was pizza. I cut a pizza into 3. Here I've got one of those pieces. That's really useful, and we've got 3 pieces there, but percentage gives us a way of comparing information. So this pizza's cut into 3. If we have another pizza that cut into 9 pieces and we want to compare how much we've eaten, we can't, because we're comparing 3 pieces with 9 pieces. We're comparing apples with pears, and it's not possible to do. So what we want to do sometimes is use percentage, and because percentage means out of 100, what we're basically working out is if this was out of 100, what would it be? So at the moment it's only out of 3, but if it was 100, what would it be? So if I just come back here, show my calculator, hopefully this will work for us. So we've got 1 over 3. To turn that into a decimal, all we simply do is do that calculation, and you'll see it looks like a divide sign of 1 over 3. So we're just going to do 1 divided by 3, which if you do that on a calculator, if you've got your own calculator, you'll see that it comes up with 0.333 reoccurring, as it's called. So that's our decimal, and decimals are generally out of 0 to 1, and 1 being the whole and down to 0 being nothing. So as a decimal, a third, 1 over 3 is 0.33. To turn that into 100, we simply times it by, to turn that into a percentage, we simply times it by 100. We know that percentage means out of 100. So we've got a set decimal. All we do is times it by 100. And that in this case would give us an answer of 33.3. And again, it's 33333 reoccurring to show with the dot. So to get from a fraction, 1/3, up to a percentage, the easiest way, or one of the easiest ways, is simply divide the number. So it looks like a divide symbol. It's a 1/3, so it's 1 divided by 3. We get our decimal, but we don't stop there. We times it by 100, and that gives us our percentage figure. If then I mentioned about this pizza, so let's say we have a third, and we have somebody else who eats 4/9 of a pizza. We can do the same with that as well. So if we do 4 divided by 9, that gives us 0.444. And if we times that by 100, that should give us 44.4%. So we can see that if you've eaten 4/9 of a pizza, you've eaten 44.4% of it. If you've eaten a third of a pizza, you've eaten 33.3% of it. So 4/9 is bigger than a third, and we can see that directly because we've got percentage. They both mean out of 100, so we can see it nice and clearly. Rather than trying to compare thirds and ninths, we do percentage, and we know that's out of 100. So that's one of the easiest ways for us to be able to compare. So that's one of the main methods to bear in mind as we go through, taking from a fraction, do division to give us a decimal, and then multiply 100 to give us a percentage. If I go back to the presentation. So what I'm going to do here is I'm going to work through some examples rather than showing you how to, well, no, I won't show you how to do it. Rather than giving you like a theoretical idea, I'm going to work through examples, and hopefully that will make what I'm explaining make more sense. So the first example I'm going to go through is about a factory. And this factory has 3,200 employees, 280 of them are managers, and we want to know what percentage of those employees are managers. So again, if I go back to the whiteboard, I have got, as you can probably see there, I have got the answers on the PowerPoint afterwards when we send it out, but I am going to work through on this whiteboard. So we had 280 people were managers out of a total of 3,200. So we could write that as a fraction, 280 out of 3,200. Just at this stage, one thing I would say, we can work out from there, but actually we can simplify that fraction. And again, if you did the fractions webinar, hopefully you'll remember this. So I'm going to do it because it's a good practice. The first thing we see is both of them end in 0. So we could divide them by 10, which in effect will just get zeros. So it's the same as 28 over 320. If we halve that, we'd get 14 over 160. And if we halve it again, we'd get 7 over 80. We can't go any smaller than that fraction. There's nothing that goes into 7 and 80 nicely. So our fraction, rather than 280 out of 3,200, will give us 7 over 80. For a percentage, we don't actually have to do those stages, but I thought it'd be good revision from the fractions webinar to do that. I mentioned before, the first thing we want to do is turn this calculation into a decimal. So we just want to do 7 divided by 80. If you've got a calculator, which I have, because I couldn't do that in my head, you'll see that that comes out at 0.0875. That's our decimal. And as I said, the last stage then is simply to times by 100, which would give us, in this case, a figure of 8.75. I'll go back to the presentation to show you that on screen. So we've got 280 out of 3,200, and we've worked that out as a decimal, as a fraction simplified is 7 out of 80. Not essential at this stage, but it's useful to do and useful revision. We then simply do that division. 7 divided by 80 is 0.0875. And because we want percent out of 100, we're going to multiply it by 100, and that gives us 8.75. So here, what we've got is we've been given some figures, and we need to work out as percentage. Our first stage was make a fraction. It's quite useful to draw it like that as a fraction. In the functional skills, you'll usually get a description such as this: a factory has so many employees, 280 managers, rather than it drawing just a fraction. So what you want to think is, well, let me draw that fraction out myself, and I know who I am. You then divide it and then times it by 100. You could be asked then, just out of interest, is what percentage of the remaining employees, therefore, aren't managers? Anybody think of, and maybe suggest in the chat, a quick way that we can work that out? We could go down the fractions route and dividing, but there's a quick way we can work out what the remaining employees are as a percentage. Anybody giving us that in the chat, Eamon?
Sorry, I was on mute. No, nothing just yet.
Nothing just yet? I'll give you a minute.
Take it away from 100.
Brilliant. So we know 100% is our maximum, and we've got 8.75. So if we just take 100 from 8.75, it leaves us with 91.25. So if the question was asking, that's the fact that what percentage of employees aren't managers, we could either do the fraction of the remaining number over 3,200, or we could work out this one that we've done there and then just take it away from 100. So sometimes you'll find there's two-stage questions such as that. So the key, if you're given figures and you need to work out percentage, the best route I would suggest is make the fraction, divide the number, and then times by 100 will give you your percentage. Right. Hope that makes sense, everyone. The other way around that I mentioned is where you're given a percentage and you want to work out the figures. I've got a couple of slides on this one. If you're working out a set number, an easy percentage, if we should say, so 50%, as probably everybody appreciates, is half. So if you've got 50% of something, you can simply divide it by 2. If you've got to work out 20% of something, that's a fifth, so you could divide it by 5 and so on. The method I'm going to go through here, even though this question's about 20%, I'm going to give you a method which works no matter how much, whatever percent you're working out. So it doesn't matter whether it's a nice easy one like 50% or whether you've got to find out 74.6%, this method will work. And the easiest way I would suggest is to work out what is 1% of the figure you're working with. So now get back to my whiteboard. So we had here, sorry if I just skipped that question, didn't I? So the question here is a car park attendant says that 20% of the cars parked are red. There are 150 cars in the car park and 32 of them are red. Is the attendant correct? So we're actually checking whether he's correct in this point, or he or she is correct in this point. So we've got 20%, but actually we're using the numbers. We know we've got 150 cars, of which 32 are red. So if we've got 150 cars, we want to know what percentage of that 32 cars is. So one of the easiest ways I would suggest is let's try and work out we want to work out what 20% of the cars is, So we want to work out what is 1% of 150. So we said percentage just means out of 100. So if we have 150 cars or 150 pizzas or whatever it might be, to work out percentage, all we want to do is split it into 100. So all we need to do is divide, which is the maths calculation we do for splitting something up, and we want to divide it by 100, which in this case gives us 1.5. So 1% in this case is 1.5, and we've just worked like that by taking our total and dividing it by 100. If we know that 1% is 1.5, hopefully you can see if we want 20%, or we just want 20 of those. And if you want 20 of something, all we do is that 1% and we times it by 20, which in this case would give us an answer of 30. The parking attendant said there were 32 red cars. We just worked out, there are 32 red cars. The parking attendant said there would be 20%, which is 30. So we know the parking attendant is not correct. So if I go back to the presentation, maybe show that step by step with the question. So there are 150 cars, 32 of them are red. Car park attendant believes that is 20%. So we took our total 150 and worked out what is 1%, which is 1.5. If 1% and 1.5, we know that 20% is going to be just 20 of those, which is 30. The car park attendant said that was how many cars are. Well, actually, there's 32. So the car park attendant isn't correct, because we know that 20% is 30 cars, and there's actually 32 cars. They were nearly correct, but not quite. One thing I'll say at this point as well is in the test, the question here at the bottom is quite clearly, is the attendant correct? So if you work out your test and you leave the figure 30, once you've done the right calculation, you haven't answered the question. The question is the attendant correct? So you would need to put no somewhere, or no, they are not correct. If you just leave the answer, you need to put, you wouldn't get the full marks without saying, yes, they are correct or they aren't. So look out for that in the test. You do have to do a calculation, but if there's a question, is the attendant correct? Then you need to make sure you've answered that actual question. We can actually check this answer, and I'll mention why this is useful as well. So there's another way that we can do this. So we just worked out what is 20% of 150, and then we compared that with 32. But the other thing we could do is work out what 32 out of 150 is as a percentage. And if we think back to the method we used before, we do 32 divided by 150. We then simply times that by 100, which gives us an answer of 21.3. So there are 21.3% of cars in the car park that are red. The attendant says it's 20%. So again, they are still not correct. So that's a way of checking our answer. So there's two methods we can use there. We could either work out what is 20% and see if it matches the 32, or we could work out what is 32 as a percentage and compare it to the 20. Benefit of that, first of all, either of those is correct. They both give the same ultimate answer that they're not correct. Within the functional skills test, you will have a number of questions, usually 3 or 4 in each test, where they ask you to check your answer. And the reason the marker is asking you to do that is they want to know, do you understand what you've worked out? Yes, you've done it, but do you actually understand it? And one of the ways to check your answer is to use an alternative method. So if this was the test and you use that method and then it said check your answer, you could then use this method and you've got the same answer, and therefore you've checked it because you've done it 2 different ways and come out with the same answer. The method we just used there for 1%, I am going to use again now. So if you're a bit unsure from there, I'll give you another example and hopefully that will show it. So the other kind of questions you've got are whether percentages are increasing or decreasing from something. And again, if I work through some examples, hopefully that'll become clear to you. So let's take this example, and I came up with this one because I actually did order a tyre yesterday and it cost more than that, unfortunately. So a customer orders a tyre from a garage and it costs £85.99, and the garage say they will fit it for him at a cost of 8%. And the question is, how much is the total cost of the tyre and fitting? So again, if I can go back to my whiteboard. So we said the tyre was £85.99. And we need to add on 8%, 8% for the fitting. Okay, we're using the method we did before. Let's work out 1%. And 1% is just going to be our total. And we want to split it into 100 because we want 1% and there's 100%. So if we divide 85.99 by 100, you've got a calculator, you'll see that that is 0.8599. Oops, sorry, 99. So we know that that figure there is our 1% figure. We need to know what is 8% of it. So simply, we take that figure, 0.8599, and we want 8 of them. So we just times it by 8, which will give us a figure of 6.8792. Again, if you're following the calculator, hopefully you'll see all that. That's a very long number. I'm going to mention something in a while, but I'm going to leave that as a long number for now, and I'll mention why in a moment. So we've worked out there that 1% of 85.99 is this figure, 0.8599, but we want 8%, so we times it by 8 and we've come up with a total figure. The question, if I remind you though, says, what is the total cost of the tyre and fitting? So what we've actually worked out there with 6.8792, that's the fitting cost. The question was, what is the total of the original cost of the tyre and the fitting? So what we now need to go back and do, the screen will let me, is we need to add on that 8%. So we'll go 85.99 plus 6.8792. And that gives us an answer of 92.87. Oops, not very good writing, sorry, 87. That obviously in pounds. You'll notice if you are following this in the calculator, it actually gives you a slightly longer number. And I'll just reset my calculator by mistake, so give me a moment. 6.872. Okay, so the answer is actually 92.8. Yeah, 8 something. My calculator's gone screwy on me. I didn't round the number at this point. I left it quite long, but I have rounded the number at the end. We're talking about money, so we don't want to say 92.86431, whatever it might be. We want to round it up to pence a pence, so 92.87. What's always good with any mathematical calculations, percentages or not, is not to round your answer until the very end. If you can keep your answers as long as they are, so 0.8599 or 6.8792, keep them as long as they can. That can get a little bit messy, but that's much more useful. It gives you a much more accurate figure at the end. If I'd rounded this figure to 0.86, I would have got a slightly different figure here and I could have rounded it again. And then obviously I'd be rounding for my answer. So that's 3 times I would have had to round, which gives you a slightly different answer, not massively different, but maybe changed by 2, 3, 4 pence, something like that. So the best tip with any maths calculation is don't round your figures until you get to the very last answer that you want to work with and then round it. So just to show that hopefully a little bit clearer on screen, there was our question. We worked out that 1% of 85.99 is just the total divided by 100, which gives us that figure. If that is 1%, then we know 8% will just be that figure times by 8. And the question was, how much is the total cost? So we need to add that new figure that we found, the fitting figure, onto our original amount, and that gives us a rounded figure of £92.87. That's an increase. The other question I said we'd look at is decrease, and this works very, very similar. It's worth thinking about the slight difference when it comes to the end. So this is a percentage decrease. The example is that a toy shop runs an advert and they have 12.5% off all jigsaws. My son said I had to call it a Harry Potter jigsaw, so I have. And we said that would normally cost £12.99. So we want to know how much that is in the sale. Back to the whiteboard. The original cost was £12.99, and we've got 12.5% off taken off. So to work out our 1%, hopefully you're getting bored of me saying this now, all we're going to do is take our original figure, 12.99, and divide it by 100, which gives us a figure of 0.1299. And we want 12.5%. So all I'm going to do here is times that by 12.5. And I'm going to do that on the calculator again, so I've got the full number for you. And that gives us an answer of 1.6235. Again, that's a long number, but I'm not going to take that long number off at the moment. I'm going to keep it as a long number as it is. The question was 12.5% off the actual Jigsaw original price. So instead of 12.5%, we know that that figure is now £12.99, take away 1.62735, which gives us a number of, if we do that on the calculator, say minus 1.62735, give us an answer of 11.36265, and we're talking about money, so I'm going to round that to £11.36. So again, I haven't rounded the initial number I've got. I've kept it as long as I can, and I've rounded at the very end. So very similar to the additional one, obviously. We worked out 1% by dividing by 100. We then needed 12.5%, so we times by 12.5. And then the total cost it asked for us is the total, take away that figure, 11.37. So in each of those last 2 or 3 examples, the first thing I've done is worked out 1%. So I said before, if you wanted to work out 50%, you could just divide it by half, which would probably be the easiest thing to do. However, what you can do is work out 1% and then times by 50. It's an extra stage to it, but it would still give you the same answer. And by going down to 1%, you can then work out any percentage going up. If you've got to work out, I said before, 79.36%, once you've got 1%, that's fine. You just times by 79.36. So going down to 1% gives you a way that you can go forward. We did a similar thing again in fractions. By going down to 1 fraction, if you've got to work out 7/9 of something, if you can work out 1/9 of it, you can then times by 7 to get 7/9. So going back to 1%, although it does give you an extra stage to do, you're dividing by 100 and then timesing by how much you need. It just means that you're in a clearer position. And as always, as you know, with the functional skills, the more working you can show, the more chance of getting the full mark. So you can show those stages in your working as well. So those are some of the main questions you will get on in functional skills on percentages. Is working out, you've got a percentage, what's the amount, or you've got an amount, what's the percentage, and then following on from that. Take questions in a moment, but hopefully you appreciate now we've gone through the relationship between fractions, decimals, percentage. If you've got a fraction, you can divide it to give a decimal, and then times by 100 to give you a result. If you've got to work out an amount from a percentage, the easiest way is to divide them, do what we just done there, divide them, then times by 100. If you've got an amount you need to work out a percentage, the best thing to do is work out 1% of that amount, and then you can times up to your percentage. That helps with increases and decreases. And probably one of the more difficult areas, but might need a bit of revision, is the reverse percentages, which is the topic I was just going. Thanks very much for listening. We'll stay on now and I'll take any questions. I'll jump on the chat as well so that I can see. But thank you very much for listening, and we will follow this up with some emails going out as well.